Hi guys, today I'm going to be working through the example question from 2.7. This is the modelling and applications, real life scenarios apparently. So this is from your Year 12 jacplus textbook, and we're going to look at this one here, which is talking about the depth of water. So look, they give us an equation for the depth of water, and this is dependent on the time, and the time's in hours, and it's after 6 a.m. And that's quite important to note that it's after 6 a.m. because, well, your 0 would represent 6 a.m. So look, what I would do when I see the equation here, I would actually sketch it straight away. And later in the question, they will ask us to sketch it, but I'm going to do it here anyway. Notice that extended response are on CAS, so you would be able to do this on CAS. I'm going to do it by hand, but as I said, it would be on CAS usually. So a normal sine function would go 1 to -1, and it would look like this with a period of 2 pi. So we're going to change the period, and that's part A, so we'll do that. A, the period equals 2 pi divided by whatever's in front of the x, and in this case what's in front of the x is what's in front of the t, and it's pi on 6. So that's period equals 2 pi over 1 times 6 over pi. Cancel, cancel. Period equals 12 over 1, which is 12. And this is quite, quite a sensible answer, because we can think in 12 hours, that's half a day, and, the water depth varies in a cyclic way, around 12 hours. So that would repeat in the next 12 hours. So there's the first bit, that's the period of function. And what that means for our graph is that instead of 2 pi, it goes 12. And this is time in hours. I should write that on. And then I should put the depth of t, and that is in meters. So now I can say the next bit would be my vertical shift going up by 2.5 units. So I'm going to put that on now as well, and actually I'll do it on the same graph, otherwise I'll run out of room. So now I'm going to be adding 2.5 to all my values. So here's a 0, and we're adding 2.5 plus 2.5 on the 1 and plus 2.5 on the -1. So we're going to end up with, actually no, I'll just move it over to the side. So we're going to end up with something that looks like this. So 1 plus 2.5 is 3.5, and 0 plus 2.5 is 2.5, and -1 plus 2.5 is 1.5. So what we see is that the graph changes to this, and this is still 12, and I can probably just put that in right away, 12, 2.5, and this one would be 0, 2.5. So this would be my one cycle of it. And it's now asking us for the maximum and minimum depths. And by drawing it either on CAS or by hand, you can really clearly see what those maximum and minimum values are. I would certainly draw it in order to see those. So the maximum depth is 3.5 meters, and the minimum depth is 1.5 meters. So that's part B. All right. So look, let's scroll down and let's look at the next one. So now we say, what is the depth at 7 a.m.? So this is this bit where, if we look back to the graph, this is 0 here, but actually 0 represents 6 a.m. So if we're looking at 7 a.m., 7 a.m. is actually 1 hour after 0. So we're not subbing in 7 into the equation, we're going to sub 1. And look, whether you do that on CAS or if you do that by hand, you would be subbing 1. If you do it on CAS, you could do this in your graphs and tables, or you could do this in main. I'm going to do it by hand, just so we get a little bit more practice with the table of exact values use. So depth at 7 a.m, I'm going to write 7 a.m. equals 1 hour after 6 a.m. So people forget that, even though I think it's reasonably obvious when I explain that, people understand that, but definitely people forget that when they do SACs and exam questions. So let's see, d of 1 equals sine of pi times 1 over 6, which is just pi on 6. I might just put that straight there. plus 2.5. So let's see. Sine of pi on 6, so that's the most important, not the plus 2.5. Our pi on 6 is here, sine, so it's half. Plus 2.5, so half plus 2.5 is 3 meters deep at 7 a.m. There we go. So fairly straightforward, I think you're probably actually better off to do it by hand, it's so quick. Let's move on. The depth of water, d meters at the end of the pier at time t hours, is modelled by this. Sketch one cycle of the graph. So we've already done that. Look, I'll just put it here just to, for the sake of completeness. 1.5, 2.5, and 3.5. Oops. So let's double check that I have 1.5, yep, 2.5, 3.5, and then we have just the ends of that graph. So it's only asking for one cycle. There it is, 12, 2.5, and then coordinates 0, 2.5. And you should definitely use coordinate points when you're graphing that. So really, as I said before, you are much more clever to sketch the function, or at least draw it on CAS, so that you can really see what you're looking at before you start answering the other questions, because most of your answers will come, you can see from the graph anyway. Okay, last bit. So now the council is interested in when the depth of the water is at least 3.1 metres. For how long, correct to the nearest minute, during a 12-hour period, is the water at least 3.1 metres deep? So this is quite a common question. I will draw it again here. 1.5, 2.5, 3.5. So if you are looking on CAS, well then we've got a line here, which I might call y equals 3.1. So if we find those intersection points there, that means that we get the x values. So let's call that x1 and x2, or maybe t1 and t2 would be more clever. And the time for which our water depth is at least that is this, and it includes those blue circles. So I've coloured them in solid because it includes that. So we want to find how long it takes to get from T1 to T2. So that's the maths that we're trying to do there. So if you're doing it on CAS, you could either find those by finding the intersection between your d of t and y equals 3.1 on graphs and tables, or you could just do this in main. And look, I would probably do it in main. You might like to look at it on the graph. It's quite nice to see it like that. This is one where you would have to use CAS because we're not going to get an exact value. So I'm going to say, well, our d of t is going to equal 3.1. So sine pi t on 6 plus 2.5, we're going to solve on CAS. Sine pi, and I'm going to use an x, equals 3.1. You can use t if you want, but just make sure you get it from VAR, not ABC. And then, well, we need to put a restriction. If you don't put a restriction, you're going to get a general solution. So to do your restriction, you put that stick, and the stick comes from Math 3. And actually the next bit comes from Math 3 as well. So we've got going from 0 up to and including 12. And then we can just, press EXE. Make sure your CAS is in radian mode, not degrees. So if you think about degrees, 0 to 12 degrees, it's not a very big space to be looking for your solution there. So it's definitely in radians. And then the answers we get are x equals 4.77 and x equals 1.23. So that's to 2 decimal places. Now, when you actually put this into CAS, you want to make sure you don't round it off too early. And in that case, I probably should write more of the decimal places so you can see what I mean. and x equals 1.2289965, and this does it will make a difference. So either leave it in exact values and do your subtraction and then only round at the end, or put all the decimals there. If the exact value is too difficult to work with, put all the decimals, and you'll see why in a minute. So we're trying to find the distance between T1 and T2, so the difference between those two values. So I could put T1 and T2 in, so what was it, 4.77 and whatever is coming after that, and 1.23, so I won't write it all here and all the decimals there. That means that the x value here, or the time, is 1.23 hours after 6 a.m. That's where it starts to be 3.1 meters deep, and then it gets deeper and deeper, and a little bit, then it goes a turning point, shallower, 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 and then when we get to 4.77 hours after 6 a.m., that's where it's too small. So then we're going to go past that, we're not where we want to be anymore. So we need to describe the amount of time that it takes to get from 1.23 to 4.77, and that's just a subtraction. So the time is going to be 4.77100,341 minus 1.2289965, and what we get for that, I'll just quickly do that, okay, is going to be 3.54200,691. Now this, if we want to put it into the nearest minute, I think it says near minute, doesn't it? For how long correct to the nearest minute during a 12-hour period is the water at least 3.1 meters deep? So at least that means it includes 3.1 meters. We've found the a decimal value there, so we can say it's 3 hours, and it's not 54 minutes. No, that's wrong. So what we need to do, we need to find what 0.54200,691 is as a part of a minute and of an hour, and that would be out of 60. So we're going to say 0.54200,691 times 60, and we get 32.52. And now when we round this, we can say that the amount of time that we are above at least 3.1 meters is 3 hours and 33 minutes. If you had rounded this too early, so if you had done, and this is the correct answer by the way, if you had done 0.54 times 60, so if you had not included that, so in other words, when you did your subtraction, you'd just done it like this, without those extra decimal places, well then you would have got, and I checked this out before, you would have got 32.4. And you would have said 3 hours and 32 minutes, and you would not have been correct. So that's because you would have rounded too soon. So that's not good. So don't round until the end. And where possible, you would want to keep your exact values. But the exact values for these are quite yuck. It's difficult to work with them, so that's why I have decimalised them, but I've used as many decimals as my CAS will give me. So that completes our example question.